Section 14B, question number 1, page 349. The question asks, for each of the following functions, 1. Discuss the behavior near the asymptotes and hence deduce their equations, and 2. State the values of the limit of f of x as x approaches negative infinity and the limit of f of x as x approaches positive infinity. So, if you don't know what the graph looks like, this is a simple reciprocal function. If you don't know what the graph looks like, what you could do is maybe choose a few test points, test values of x, substitute it into the function, and then determine what the general shape of the function. So I kind of know what this looks like, so I'm going to give myself a little Cartesian plane here. And I'm going to draw a general sketch of what the function looks like, and I know that it kind of swoops down like this, and the negative side over here as well. So that's generally what it looks like. So the function is 1 over x, and I need to discuss the behavior near the asymptotes and then deduce their equations. So when I look at this, I see that, actually when I look at the function itself, I know that you cannot divide by 0, so therefore the function cannot exist when x equals 0, therefore the vertical asymptote is when x does equal 0. So that's the first part. Secondly, when I want to look at the horizontal asymptote, and the horizontal asymptote only applies when x is very, very large. Very large positive values of x and very large negative values of x. And we want to see where the function goes, and what values it approaches as x gets really, really large. Well, as x approaches negative infinity, I see that f of x approaches 0 from below. And as x approaches positive infinity, I see that f of x approaches 0 from above. As x is going to positive infinity, f of x approaches from above. So therefore I know that the horizontal asymptote is y equals 0. Okay, so now if I take a look here, so that's one part of it. That's the horizontal asymptotes. Then when I look at the behavior of the graph as x approaches the vertical asymptote from left and right, as x approaches 0 from the left, let's start from the left, I see that f of x is approaching, so from the left, I see that f of x is approaching negative infinity as it goes down. And then as x approaches 0 from the right, as it goes towards the right, we see that the function goes to positive infinity. So I kind of cheated. I didn't find the asymptotes after examining the behavior of the function as it approaches or near the asymptotes. I found the asymptotes first. I find that a little bit easier, and then evaluating or examining the behavior of the graph around those asymptotes. So now what we need to do for part 2, which I've kind of already done around the horizontal asymptote, we want to state the limit of f of x as x approaches negative infinity. So as x approaches negative infinity, we see that this limit is 0, and the limit of f of x as x approaches positive infinity, so as it goes towards the right, that equals 0 as well. Now if we move on to question B, same sort of idea. The function now is a little bit more complicated. It's 3x minus 2 over x plus 3. And what we're going to do is we're going to do the same sort of thing. We're going to first of all find the vertical asymptote. So if I take a look at this, I know that you can't divide by 0, so that means that the function does not exist when the denominator equals 0. So the vertical asymptote would be when the denominator equals 0, which is when x equals negative 3. Now, to get a proper sense of what this function looks like, you can do a couple things. You can plot a few points, like I said, for part A. Choose a few values of x, substitute them in, and find those values. The other option is, once we know there's a couple asymptotes, we know there's going to be a horizontal asymptote there, which I'll show you in a minute. We know we just found the vertical asymptote. We can get a sense of what the function looks like by plotting the x and y-intercepts. So I'm going to find the x-intercept and then the y-intercept, and then from there that will show us what the graph looks like. Okay, so for the x-intercept, we know that all the way along the x-axis we know that y equals 0. Just give myself a little Cartesian plane again here. So all the way along the x-axis, y equals 0. So for the x-intercept, y is going to equal 0. And then I substitute y equals 0 here, so I get 0 equals 3x minus 2 over x plus 3. I multiply both sides of the equation by x plus 3, which cancels that out. So we're left with 0 equals 3x minus 2. And then we solve for x, so we isolate the x. So we'll add 2 to both sides, so we get 2 equals 3x. And then we divide both sides by 3, so x equals 2 over 3. So that's the x-intercept. So if I were just plot a couple points here, is not super accurate, but 2/3 will be around here. That's the x-intercept. And then for the y-intercept, I know for all along the y-axis, all x values equal 0. So then when I substitute 0 in for x, I get y equals, and then we get 0. I'll just do that substitution. So y equals, and then that goes away, so we're left with negative 2 over 3. So, actually maybe I'll do this formally here. The y-intercept is 0, negative 2/3, and the x-intercept is 2/3, 0. Okay, so then I plot negative 2/3 here. And we know that the vertical asymptote is at x equals negative 3, so I can plot this, or graph the drawing the vertical asymptote at x equals negative 3. And then right now we can already see from the x and y-intercepts kind of the shape of the graph that's going to occur. Okay, so we know it's going to go through here, it's going to now go down, approach the vertical asymptote from the right, go down towards negative infinity. The nature of rational functions, generally if they're kind of simple, is we'll have another branch that will be over here going up. As it approaches the vertical asymptote, is going to go up towards positive infinity. Now the one small thing now we have to do is we have to find out what the horizontal asymptote is. And the horizontal asymptote is what I usually state because I mentioned this before, the horizontal asymptote only applies for very, very large values of x. So I call this the, and I'm not sure if I necessarily should drop names or mention names, but there are rich people in the world, and there's no harm in mentioning their names. They've worked hard for their money, etc. So I call this the Bill Gates rule of finding horizontal asymptotes. We see we got 3x minus 2 over x plus 3, and so I say, well, if Mr. Gates was walking down the street and he found $3, would he stop and pick it up? Or would that have, that $3 extra, would that really have a huge impact on his bank account? Not really. So we can just ignore that. Same thing if he's walking down the street and he loses $2. Will that have a huge impact on his wealth? Not really. So we can cancel that out. So we can say that that equals 3x over x. Now we simplify, and that gives us 3. So the horizontal asymptote is y equals 3. So now what I can do is I can just draw in the horizontal asymptote at y equals 3. I'll put that up here. And I'll have to extend my y-axis a little bit here. So now basically what's happening is now the graph is taking shape. We know that it's going to be coming like this. It's going to be going towards that horizontal asymptote from below as x gets really, really large positive. It goes down to negative infinity, or approaches negative infinity as x approaches the vertical asymptote from the right. And then over here it's going to approach the vertical asymptote from the left and go up towards positive infinity. And it's going to approach the horizontal asymptote from above as x gets really large negative. So that's the basic shape of that function. And sorry, it's kind of cramming into question A there. So that's the general form of the function. So then if we do our analysis of the function, we need to discuss the behavior near the asymptotes. So in part 1, as x approaches negative infinity, or sorry, negative 3 from the left, so as x comes along here towards negative 3, which is the vertical asymptote from the left, we see that, and I'll just write this down below because I'm running out of room, f of x approaches positive infinity, and then as x approaches negative 3 from the right, so from this side, we see that f of x approaches negative infinity. And then around the horizontal asymptote, as x approaches negative infinity, f of x, so as f of x approaches, or sorry, as x approaches negative infinity, f of x approaches the horizontal asymptote of 3 from above, and then as x approaches positive infinity, as x goes to the right here towards positive infinity, f of x approaches that same horizontal asymptote of 3 from below. And then for part 2, we have to find these limits. So the limit of f of x as x approaches negative infinity, well, we've already done that, equals 3, and the limit of f of x as x approaches positive infinity also equals 3.